Okay, let's take a look at the blood donor and recipient compatibility worksheet. You may have been able to get through this okay, and you're just using this as a review, or perhaps you're just checking your answers. Maybe you're at a spot where you didn't feel real confident when you got out of the first lecture, and this is sort of a teach slash reteach. But regardless, I want to walk you through this and give you an example or two on the bottom. Remind you how this little chart can be helpful, and that should pretty much wrap it up. So first up, we're looking at donor, which is to give, and recipient, which is to take. So blood donor would basically be someone who's giving their blood to someone else, and a blood recipient would be someone who's receiving it or taking it. So we're at a spot where we have talked about blood types and their importance, thanks to the work of Landsteiner and coming up with this ABO naming system. And I guess you could kind of make an argument that we talked about two ways that understanding blood types is important. Since this is forensic science, we'll go through that first. So why is it an understanding of blood types important? I'm just going to put in, and then I'll abbreviate here, forensic science. You can ID with blood type. So does that mean that if I'm type A positive blood and type A positive blood is found at the crime scene and they know it wasn't the victims, that I for sure did it? No. So maybe to say ID is a little bit extreme. Maybe to say, narrow down or perhaps warrant further investigation would be a bit better. But if I'm type A positive blood and A positive blood is found at the crime scene, that might warrant something like a DNA test or perhaps some more investigation into my background and whereabouts. In the grand scheme of things, the reason why blood types and understanding them is important for transfusions. If you don't know, or I should say if a doctor or a surgeon doesn't know which blood type you have, which blood types they have, and if there's going to be a problem if you receive them or not, yikes. Remember, like we said, if you get a different protein into your system, your body could treat that as a foreign invader, could clump up your blood, and it actually could be fatal. The reverse of that is, man, if you can't get good blood type, you could have some real problems. I mean, if you bleed out during a surgery or an accident or whatever, that too can be fatal. So the ABO naming system, what is it? How does it work? I would say that the ABO naming system tells the proteins on, and I'm going to abbreviate here like we were using from lecture, RBCs, or your red blood cells. You could probably add that it also tells what proteins aren't on a red blood cell, because sometimes that's some pretty valuable information as well. But basically, when you get a blood type name, that'll tell you right out of the gate which proteins are on the surface of this red blood cell. So we started off with just the ABO part, right? And you could have type A, you could have type B, you could have type AB, where we said both of those proteins are present, or type O, that's going to be no proteins are present. So some common mistakes that I told you to look out for. Some kids will think, well, yeah, all right, there's an A protein, a B protein, an O protein. No, no, no. There is no O protein. That's the absence of both the A and B protein. And if you're type AB blood, that means that you have both the A protein and the B protein. Then we started to look at the work that Weiner did with the rhesus monkeys. So rhesus, the first two letters there is RH, and the RH factor is going to be another protein on RBCs. Remember, this is where you're going to be positive or negative, and a common misconception is, okay, well, if I'm positive, I've got RH positive, and if I'm negative, I've got RH negative. No, no, no. If you're positive, this RH factor is present. It's there on the red blood cell. If it's not, then that's going to be negative. So as far as how common it goes, we said about 85% of the population have it. So when we're looking at the major blood types, right, we've got A, B, O, the ABO naming system, and A, B. And now we're saying there is positive and negative. So basically I've got positive, 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 1, 2, 3, 4. And then I've got 1, 2, 3, 4. I could have those in negative. So if I've got 4 positive, 4 negative, that would be 8 total types, right? So we're going to later on get into calculating probability, and we're going to look at some other proteins and enzymes that are common on red blood cells. But these are really the major ones where if like you went to the doctors or something that they would have to be concerned about. So what blood type's considered the universal donor? In other words, who can give? If we say something's universal, it's just like a catch. It fits for everything. And the one that can give to everybody is O negative. It has no proteins. So that would be just basically a blank red blood cell. So if we look at what would be then the universal recipient, who can receive all blood types, who can get every single blood type, and they're not going to have any problems, which is another way of kind of saying, all right, who can take blood types and they're not going to have any proteins in their system that they're not used to or that their body would treat as a foreign invader. So that means that they're going to have to be used to the A protein, the B protein, and the RH factor. So with that being said, AB positive is going to be the universal recipient. Why? All proteins. All right, hold on. I got a dog barking at the door. All right, sorry for the delay there, kids. When you're recording these things from home, all sorts of stuff can pop up that you didn't plan for, like dog barking and kids and wife that apparently are deaf to that sound. I digress. We move on to this bottom part here. And taking a look at this, you've got your positive, negative blood types. We're asked what proteins are present on the surface. And we're asked what blood types could that receive and what blood types could that donate to. And I would hope it's implied here, but that would be for which ones it can safely, receive from or donate to. So if I say there's a blood type that's A positive, what that tells me is that the proteins on the surface of that red blood cell, you've got the A protein and you've got that RH factor, that RH protein. So if we look at that in contrast to A negative just has the A protein. So a common thought is, oh, well, has RH positive, and then this must have RH negative. No. Remember, if it's negative, that means that the RH is not there. If it's positive, it is. So another thing that kids kind of mess up on is they forget that blood types can always receive and or donate to themselves. So there's a few ways that you can kind of think these through. This is just how I do it. If this happens to be A positive and I'm asked, well, what blood types could that receive from? I put that down first. All right, so that can for sure receive A positive blood. So since I had A positive here, I just kind of worked through the positives first, and then I work through the negatives second to see, all right, well, which ones are which. This is what I mean by that. Okay, if that's A positive, what blood type could it receive? So B positive. Could this guy receive B positive blood? In other words, if B positive blood goes into this guy, is he going to have a problem with that B protein? Yeah, he is. So this person or she, this person cannot receive B positive blood. But Cash, they're both positive. That's true. That RH factor is not going to cause any problems here, but that B protein will. So then that rules out AB positive, right? Because that would have the A protein, the B protein, and the RH, and that B protein would cause a problem again. Could this person receive O positive blood? Yeah, because the O just tells me there is no A or B. Remember, you don't have to get the proteins that you naturally have. Otherwise, you could only receive your own blood type. And the positive, well, they've got that RH, so that's not a problem. So now I can kind of go to the negatives. Could this person receive A negative blood? Sure. The A is not going to bother that person. Cash, though, they don't have the RH. Yeah, remember, you don't have to get all the proteins. There's nothing that would be introduced into this person's body that would cause some problems. So could this person receive B negative? No, remember that B problem is going to cause a B protein would cause a problem. So this person can't receive AB negative or positive. Could they receive O negative? Sure, everybody could receive O negative. I mean, I guess if you wanted to, you could kind of almost say, well, I'm just going to draw a line down and, O negative goes into all these guys because it's going to be the universal donor. It can give to everybody. So that should wrap that up. With this little chart, I'm not going to put it on tests or quizzes or anything like that. I'm never going to ask you to fill it out. I just put it down here because it was something that I referred to in lecture. And my hope is that you'd kind of try to think this through. And then maybe you could use this as just a quick check. So A positive, who could it receive from? So if I jump down to A positive, and on my y-axis here, I've got recipient. On my x-axis, I've got donor. So there's A positive. Who could it receive from? We said both the O's, both the A's. Bingo, bango, bongo, woohoo. Looks like we're in good shape. So now I want to think through who could this donate to? I know everybody can donate to themselves. So I'm just going to say, all right, well, if I've got A positive blood, could I donate to someone that's A positive? Sure. Of course, you can always donate to your own type. And I'm keeping that same logic. Let me tackle the positives first. So could A positive donate to B positive? Because if that person was B positive, this A protein is going to mess them up. So could this person donate to AB positive? Yeah, they could. In fact, everybody could donate to AB positive. Remember, that's considered the universal recipient. So this guy could donate to this guy. A protein goes in, no problem. Positive goes in, no problem. Cash, they're not getting that B protein. That's okay. As long as they aren't getting a new protein that their body would treat as a foreign invader, they're in good shape. So could this guy donate to A positive? Sure. We said no B positive. We said yes, AB positive. Everybody can, right? That's going to be your universal recipient. Could they donate to O positive? Well, they both have the positive, but if I tried to give A positive blood to someone who's O positive, this A protein is going to cause a problem. So I think I'm done with my positives. And now here's kind of sometimes an easy way you can chunk things. If this person has that RH factor, in other words, they're positive, is there any negative blood type that they could donate to? No. Not safely, right? Because no matter if it's A negative or B negative or AB negative or O negative, they're going to have that positive. So I don't even have to really think about any of the negatives here. So I think I'm done. I can use this little flow chart to double check. Remember on my x-axis here, I've got donations or who they could donate to. I was looking at A positive. They can donate to, the universal recipient that everybody can of AB positive, and they can donate to themselves, and that is it. So it looks like I did okay on this. So rather than continue to show you that I know how to do this, what I'd like you to do is see what you can do on this without using the chart at the bottom. Double check with this guy to see how you're doing. I can post a key on my website later. If you've got specific questions, please let me know. Hopefully that sheds a little light on this and you got something out of it. Take care.